All right. So we said that f of x equals x to the fourth plus c was the general solution for the derivative f of f times x to the third. When we are, and you had this in your notes, if we were going to designate that we want to take an antiderivative, y is equal to, this is your integral sign. It means we're going to take the antiderivative. He said something about like it's a large S. Later when we look at area under the curve, which has to do with antiderivatives, we'll see we're taking the sum of those areas, so this is an elongated sum, is where that symbol came from. But this is our integrand. It's called an integrand. This is our variable of integration. This tells us what the variable of integration is. Because you could have dr, and so your equation would be an r instead of x. You could have dt, so your equation would be in t instead of x. So we can tell what variable we need based on what this is. Because you could have the antiderivative of 2 dx, so you know that it needs to be an x. Or you could have the antiderivative of 2 dr, so your equation would be an r instead of x. So that's helpful in telling us what the variable we're going to use is. And this is always equal to the function plus c, and c is called our constant of integration.
Why is that a capital?
Just in this instance, I just chose to use a capital F to differentiate from little f. I'll show you another way we could do it. One is the derivative, the little f is the derivative.
Why don't we just write it?
You can. I've just said I'm going to show you another way it can be done.
So what does that say? Constant of integration?
That c is your constant of integration. That just represents some constant without an initial condition. We don't know what that constant is. If you're given an initial condition, you can find it. Right? As long as we don't have numbers at the bottom and the top of our integral sign, we're going to have an equation for our answer.
So is the other f of x just the function?
The big f of x is the function.
The original?
Little f of x is the derivative of big F of x. Another way, now maybe it would help you, it's different books write it different ways. You could do it this way. Y equals f prime of x dx, and so we get f of x plus c. Just another way to write it. But what the integrand is the derivative of this function here. Yes, ma'am.
Okay, I know you said that it doesn't have to be capitalized, like the derivative one, but does the one on the other side have to be capitalized? Or does that not matter?
It doesn't. I'm not going to get picky on that because you're not going to be having f of x in your answers. You're going to have an actual equation. You will have an actual equation. Now, I said that before I started recording that finding a derivative and finding an antiderivative are inverse functions. In other words, they undo each other. So if I took the derivative of the antiderivative of f of x dx, what do you think we would get?
F of x.
Just f of x. We don't have to put the dx. It's just going to be f of x. Because these two undo each other. All right? Sir? They cancel each other out. Like if you, multiplication and division undo each other. They're inverses of each other. But cancel each other out is a good way to say it. All right, now let's look at some properties of integration. Okay, we talk about integration, indefinite integral, antiderivative, We're all talking about the same thing. So if this is the derivative form, if I take the derivative of a constant, what do we get? 0. So if we take the antiderivative of 0 times some dx, which tells us our variable of integration, we're going to get a constant. If we take the derivative of a scalar times x, scalar is simply a real number, what do we get? We just get k, whatever k is. So if we take the antiderivative of k dx, we're going to get kx plus c. Trying to show you the relationship between the derivative and the antiderivative. If we take the derivative of k times f of x, we know this is going to be k times f prime of x. So as far as an integral is concerned, if we take the antiderivative of k times f of x dx, I could actually rewrite that by moving that scalar out front. Since we don't know what f of x is at this point, I can't really take that any further. If I knew what f of x was, I could go ahead and do some more with it. But we can always move this k to the outside. You can move a scalar, a number, to the front of the integral, and sometimes that makes it easier to calculate. Right now we're just looking at some basic properties of integration. Grace?
Yeah, does that say k and then the integral sign f of x dx? On the
Yes, yes.
So you can move it outside of that.
We can move it as long as it's multiplied by the function. You can move it to the front. And sometimes that makes it easier to calculate. Right? If we have the derivative of a sum or difference of two functions, we learned that we could just take f prime of x plus or minus g prime of x. Well, we can do the same thing when we're taking an antiderivative. If we want to take the integral of f prime of x plus g prime plus or minus g prime of x dx, we can write that as two separate integrals. So they can be separated. Sometimes that's helpful, sometimes not so helpful, but you can do that if you want to. But those are just some properties. Let's look. You saw this rule when you watched Khan Academy. We said that if we take the derivative of x to the n, that is equal to n times x to the n minus 1. As long as, I can't remember if we had a restriction there. I don't think we did. But when we take the antiderivative,
Well, it's just the power rule online.
yes, just the power rule. This is the reverse power rule. This becomes x to the n plus 1 over n plus 1 plus c, but n cannot be equal to negative 1. Do what? Yeah. I can see it on my screen. But. All right, so n cannot, we cannot have
Like it will never.
n, well, to use the reverse power rule, it won't. If n equals negative 1, then the antiderivative is the natural log, which we'll talk about later.
Okay.
Right now, we just want, n can't be -1. We can't use the reverse power rule if n is -1. It doesn't apply. Nan, you have a question?
Yeah, at the first line, after the antiderivative, is that k times the f?
Yes.
F1 it should be derivative of the fx, right?
Yeah.
Wait, what did you just do?
Thank you.
Oh, that, okay.
All right. Now let's think about trig functions. Can I just move this all out of the way? You're not done copying?
Which part did you change? Susan?
Right here.
Wait, what is that?
You changed that to what?
I didn't have the prime.
Wait, why is it?
Where is that?
Oh,
All right. Move this out of the way.
You changed both of them or just the first one?
both.
I had it on both of them, yeah.
Why not just the first one?
Because I just rewrote the first one with the constant on the outside. All right. The derivative of the sine is what? So, the antiderivative of the cosine x is sine x. Oh, dx. Don't let me forget my dx. Plus c.
So can we just safely assume that we need to add c every time?
Yes. In fact, it's incorrect if you don't have a c, unless you're given an initial condition and then you'll solve for c.
What do you mean by like initial condition? Like, will it?
I haven't given you one yet, so we'll get to that.
Okay.
Like at x equals 0, it tells you what y is when x is 0. Or when, Olivia, did you have a question? Okay. The derivative of the cosine of x is negative sine of x. So the antiderivative of the sine of x dx equals negative cosine x plus c. Going backwards.
Can you not take the derivative or the anti-derivative like negative sign?
Well, if you had a negative sign, then it would be a positive cosine.
Okay.
But if you're given the antiderivative of the sine, it's the negative cosine.
But if it were negative sign, it'd be positive cosine?
Yes.
Wait.
Okay, notice here, the derivative of the cosine is a negative sign. Let's take the derivative of negative cosine. What do you get? Sine, which is what we started with right here. You can always check your work. Plus C. Every one of them has a plus C. You can always check your work by taking the derivative of what you got, and it should match this. Okay, if you want to check it, you take the derivative of your final answer, and it should match your integrand.
Okay, but you're doing the derivative of the negative sign, aren't you? Yes.
No, I took the derivative.
If you have the derivative of cosine equals negative sign, wouldn't you be doing the antiderivative of negative sign?
No, if you take the derivative of a negative cosine, what do you get? Sine, which is what we had right here. We're just checking our antiderivative to see if we did it correctly.
Then why did we write dx and cosine?
The antiderivative of the sine of x dx is a negative cosine of x plus c.
Ms. Coleman, she just asked where you wrote it next to the derivative of cosine equals negative sine of x. Is that just
Because the derivative of the cosine is a negative sine of x.
yes, they're both true statements, but they go.
They don't coincide like the first one. Yeah.
No, because of the negative, it looks a little bit different. The negative actually goes with the antiderivative.
Okay, gotcha.
Okay?
Antiderivative of negative sine.
It would be positive cosine.
Okay, yeah, so we just gotta skip this question.
Yes, yes. But you're not very often are you going to take the antiderivative of a negative sign.
Why not?
Because usually that's not the problem.
That's why.
What's the derivative of the tangent of x? Secant squared x. So the antiderivative of the secant squared x dx equals tangent x plus c. On quizzes, if you don't have your plus c, account off. Okay.
Even when it's not the plus C.
Well, no, don't put a plus c if it doesn't belong there. But
Like, slightly, so it'll be like, oh, I erased it. Or you didn't erase it.
Oh, you just told her you were gonna do it, congrats.
It's okay.
what's the derivative of the secant of x?
Negative.
Secant x tan x.
Secant x tan x. So the antiderivative of the secant x tan x dx equals
Secant x plus c.
secant squared, oh, secant x, you're right, sorry. Let me erase that. I may be too late. Yep. All right. And derivative of the cotangent of x?
What is it?
Cosecant x squared.
Is this cosecant or cotangent?
Negative cosecant squared x. So the antiderivative of the cosecant squared
Negative cotangent.
is a negative cotangent x plus c.
Okay, now I see what you did.
Okay.
I was confusing me before because it was not lining up.
And they're supposed to put dx after the.
Yes, there's a dx right there. Thank you.
We're getting it.
Now, I have noticed that on the AP, we need to put it there. We need to put the dx there, but they usually won't count it off if you forget. But we need to do our best to remember to put it there.
Where do we have to put it?
In the
Right here,
This dx, it doesn't like really, I mean, it doesn't represent anything, it's basically just saying this is a.
the variable of integration.
It's kind of like saying, hey, you're using x.
We're using that differential equation, dy equals f prime of x dx. What is the derivative of the cosecant of x?
Oh, so, okay, so our equals is like the dy part, right?
Negative
F prime part.
cosecant x cotangent.
Okay, so the antiderivative of the cosecant x cotangent x equals dx equals negative cosecant x plus c.
Wait, what is, oh, this is that cotangent.
what happened? Tangent.
It's right there.
Wait, never mind, sorry, forget it, sorry.
All right, let's find the antiderivative of 5x dx. Now remember, I told you can move the 5 to the front if you want to. This is the same as saying 5 times x dx. And if we use the reverse power rule, we're going to have 5 times x to the 1 plus 1 over 1 plus 1 plus c. That's the answer. If you want to write it as 5 halves x squared, that's fine too. We use that reverse power rule. You add 1 to the exponent and you put your new exponent in the denominator. Now, notice, and I think he mentioned this, because I always forget to mention it, if we took 5 times this whole thing, 5 times c is still a constant. So you don't have to worry about multiplying this 5 times that c, you can just put plus c. You don't need,
No.
Probably not, but that's not very mature.
Can you just?
Calculus wise, I would say that would be an immature use of it, but.
I just don't
Which
know.
you have, I know in the comic book, they put a little C.
They did, but
One, you don't have to.
you don't have to do that because any constant times a constant is still just a constant. All right.
It's almost like you're multiplying it by zero to zero C. So you multiply something times a constant, it's still gonna be a constant.
So what
Yes.
It's not very mature.
She's immature.
And I don't mean that. I'm just, there's levels to, it makes you more professional. Would that be a better way to say that?
No, I like mature.
All right. Let's look at this problem. What might I want to do here, do you think?
Put the X up top.
Put the x up top. It'll be a whole lot easier if we put the x up top. So x to the negative 4 dx. Now we can use that reverse power rule, which says we'll have x to the negative 4 plus 1. And what is negative 4 plus 1?
3.
Over negative 3 plus c. So this gives us x to the negative 3. I put that negative out front. And now we'll just bring it down. We don't like to leave negative exponents. If we take the derivative, say from this step, what would you get? Negative 3 times negative 1 is a positive 3 over 3, so those cancel. And negative 3 minus 1 is, so we got what we started with. All right, let's look at another one.
Are you kidding me?
Okay, how can I rewrite this one, Olivia? How would I rewrite that one? X to the 1 half.
Nice, dude.
Nice, dude.
So, what's 1 half plus 1? 3 halves. Over 3 halves. But that's the same as saying 2/3 times x to the 3 halves plus c.
And can we leave it like that?
That's your answer. If we were to take the derivative of this, 3 halves times 2/3 is x, and 3 halves minus 1 is 1 half. We'd get x to the 1 half.
So, will the top, like how it's x to the over 3 halves, is that always gonna be like the same? Like, is it gonna look the same?
When you take the antiderivative using the power rule, the new exponent becomes your new denominator.
Okay, so they're always gonna be like the same number. Yeah.
All right, let's look at twice the cosine of x dx. All right, twice the cosine of x dx. If you want, remember you can move that 2 to the front. What's the antiderivative of the cosine?
Negative sine x plus c. Or are you doing
Sin X.
Sine x. So twice the sine x plus c, because what's the derivative of the sine?
a negative cosine?
Derivative of the sine is cosine. All right?
I don't get how that So we should just test it, I guess?
Test it. Until you get comfortable with it, test it. And when I say test it, check your answer. Find the derivative of your answer. Paul?
So when we start taking quizzes and tests like that, will you give us enough time to go back and check stuff like that? Might add like an extra minute or two to each question.
Well, you need to learn how to speed things up a little bit.
community class.
Because you're not, when you get to college, they're not going to give you, Mr. Burnett's, let me,
Oh, wait.
X
Thank you.
X plus C.
plus C.
Yeah.
I had it. I was like,
All right, if we had had the antiderivative of dt, it would
T
be
plus C.
t plus c.
What's DT?
I don't know.
That dt, that tells you your constant of integration. It's the same as dx, except we're using t instead of x.
it just changed up in the letter.
So is D's constant? Is your pencil?
You'll always have a d something. It's not d times, but you'll always have a d something. All right. You do this one. What did I tell you? If you wanted to, you could rewrite this as x dx plus 5 dx.
That actually helped.
Oh, then we do those separately.
Then you can do them separately. Carly, did you get it? Not yet?
I just talked about Alice. Which Alice is blowing my mind.
Wait, what does that say? All the way to the right.
That's me trying to figure out. Anna's light bulb.
What's the antiderivative of x? X squared over 2, or 1/2 x squared, because 1 plus 1 over 2 plus
0.
5x plus c.
There we go.
Why is it 5x?
Because you have a 5 right here.
It's like X.
Derivative of 5x.
5.
Remember we said we could move that 5 to the front if we wanted to.
What do you mean when you move to the front?
You multiply it by whatever you get. Shh.
Move that up.
Okay. 5 times x. It's 5 dx, so it's 5 times x. All right. What might we do here? Rewrite it. I'm not going to move it up.
Bring the X.
No.
All right.
But can you bring that up?
And then you can move it up after that. But you get x to the negative 1/2, and then you just have to like probably get.
We can rewrite this as x over the square root of x dx plus 1 over the square root of x dx, which becomes x to the 1/2 plus x to the negative 1/2.
Wait, why did you go like
So you have 1/2 x and then
Yeah, x to the 1/2 and x to the negative 1/2. All right, so we just rewrote that. Remember, a lot of times I would tell y'all when you're taking a derivative, it's if you can simplify it before you take the derivative, that's what you want to do. So if we use the reverse power rule, what's x to the 1/2 plus 1/2?
2/3.
What's 1/2 plus 1/2?
Wait, where are we? Wait
Uh,
a second. Why don't you just add 1? I thought it was 1/2 plus 1.
Oh, you're right. Thank you. Thank you for paying attention.
I was thinking that. I was like,
Thank you. Okay, so 3/2 over 3/2, but that's the same as saying
2/3.
times 2/3. Okay, we would have a plus c. I can put it there, but you don't have to because we're going to end up adding the two constants together. What's x to the negative 1/2 when we take the antiderivative?
Negative, 1/2. 1/2.
1/2 over 1/2, which is
So 1.
2. So your answer
that?
is 2/3 x to the 3/2 plus 2x to the 1/2 plus c, because one constant plus another constant is
So
c.
you don't have to add the two CC's.
You don't even have to put this one.
Oh, okay. Yeah.
I just didn't want you to forget that if you didn't have that second part, you'd need it. Okay. Let's look at this one. Notice a lot of times we have to rewrite.
Yes, we do.
We have to rewrite our equations because we can't get there directly. Like the last problem we did, we had to rewrite it so that we could take the antiderivative. So here, I don't have anything that helps me with cosine squared, taking the antiderivative, especially if it's in the denominator.
Would it be 1 over cosine?
But we can rewrite this as 1 over the cosine of x times the sine of x over cosine of x. Now, what is 1 over the cosine of x? Secant x sine over cosine.
Tan.
Now, do we have an antiderivative for
We
secant
sure
x
do.
tan x? What is it? Secant x plus c.
That's cool.
All right, there's your homework.
Don't be kidding. No, she can just